Hey guys, how's it going? Guys, just want to start off. This will be the first lesson for Math 20-1 online. And the lesson's called, it's in the unit called Sequences and Series. And the first topic is what we call Arithmetic Sequences. Okay, so talk about this, guys. So this is kind of I'm going to say one of kind of 5 topics that we do. So in this unit, we have the first one is called arithmetic sequences, then we have arithmetic series, then we have geometric sequences, geometric series, and then we finish off with a topic called infinite geometric series as well. In your notes in the context section like that, I think they kind of stretched out into a few more sequences, a few more lessons in this, and there's kind of a few quizzes that you guys have to do online with this as well. So I'm just going to show you a few examples for this topic, and guys, hopefully it makes sense. All right. Okay. So the best way that you guys should be kind of using these video notes is I'm asking that you guys try to do the question first on your own. Okay, so if you're watching this video, just take a moment to start a question like this. Print out the PDF. It'll be there in the content section of the course as well, and then kind of print out the PDF and then kind of pause the video, try the question first, and then see if you can figure that out. Okay, so so example 1 says determine the next terms in the sequence. We have 6, 15, 24, 33. So hopefully the idea that we're going for here is, sorry guys, my pen is not working here right now. Give me a second. All right, 1 second. All right, okay. So the idea for this question here is that if we go from 6 to 15, that we're going plus 9. So 6 plus 9 is 15. And then if we go over here again, 15 plus 9 is 24. And then 24 plus 9 is 33. Okay, so you will have seen questions like this, at numerous points like that. It's probably called patterns like that. Okay, so follow the pattern. What are the next 2 numbers in the pattern? Okay, so all we're doing as well, instead of saying the word pattern, we're saying the word sequence. And below over here in mathematics is a sequence is an ordered list of terms. Okay, so if I can kind of keep following this pattern over here, so the next term in my sequence would be 42 and then 51. Okay, so this is by going plus 9, 33 plus 9 is 42. And the same thing, 42 plus 9 equals 51. Okay, so with the first example like that, nice and easy, we're just kind of filling this one over here. All right, so given the sequence 1, 1, 2, 3, 5, 8, 13, determine T4, T5, T9. Okay, so what's tricky about this over here? So first of all, this is not the same type of sequence we had before. Okay, but there definitely is a pattern here, but we need to be able to figure it out. What this means here, T4 means the 4th term in the sequence. Okay, so looking at this, now it doesn't mean the 4th term after this point, it just means term number 4. So this is term number 1. So this guy would be like T1, here's T2, here's T3, here is T4. So T4 is just equal to 3. Okay, T5, same idea, is equal to 5. This would be T6. This would be T7. Okay. Now for the last one, T9, bit of work we have to do over here, but we need to figure out, extend this pattern for 2 more terms to get T8 and T9 to figure out what this guy's going to be. Now, if you stare at this for a second, guys, where are these numbers coming from? This number comes, so this number 2 comes from 1 plus 1 is 2. And then 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. So the way the sequence works is that the term is equal to the sum, which is adding the previous 2 terms. Okay, so 5 plus 8 was 13. So my next term, if I was to continue this on over here, would be comma 21, because 8 plus 13 is 21, and then 13 plus 21 is 34. Okay, so T9 in this case would be 34. So the idea about this is just talk about terminology here. When we say T4, we mean the 4th term in the sequence. T5 is the 5th term. T9 is the 9th term, and so forth like that. Example 3 says classify each type of sequence. Okay, so in these 3 sequences we have different patterns over here. We have to identify what those are. First one, we have 5, 10, 20, 40. Hopefully what you recognize is that what we're doing here is that we are multiplying times 2. Okay. What's different about example B here is in this case, we are adding 8 every time. Okay. In this one over here, it's something different over here. But what I'm going to say is like we add the previous 2 terms. All right. So what this is getting at is we have kind of 3 different patterns over here. Okay. The first one, when we're constantly multiplying by the same thing, we call this a geometric sequence. All right, so what I'm going to say is consecutive terms have a common ratio. Okay, the ratio means like if we're multiplying, so if I go 10 and 15, the ratio between these two numbers is 2. 10 divided by 5 is 2. 40 and 20, 40 divided by 2 is 2 as well. 40 divided by 20 is 2 as well. Okay, so if I take this term divided by this term, I get 2. Or if I take this term and multiply by the common ratio, I get the next term like that. Okay, so this is how what we call a geometric sequence. We're going to study this in 2 lessons from now after this. This one over here is what we call an arithmetic sequence. Now, it's different because in example A, we were multiplying the same thing to get the next term in the sequence every time. In this case, we're adding a term. We're adding 8 to get the next term every time. So in this case, consecutive terms have a common difference. All right, now the last one is kind of a fancy one over here, but we call this guy the Fibonacci sequence. I hope I'm spelling that right. Okay, and the way the Fibonacci sequence works is you're always, if you add the previous 2 terms, like 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, and so forth. That's how you get the next term. You just keep adding the previous 2 terms. Okay, so this is what's different. Now, we're not going to study the Fibonacci sequence in too much detail. We'll probably refer to it a few times back throughout the rest of this unit, but we're not going to discuss it too much. We use geometric sequences and arithmetic sequences. We're going to study these 2 types in this unit. All right, okay. So example 4, derive the general term formula for arithmetic sequences. Okay, so what I'm going to do over here, I'm going to give an example of an arithmetic sequence. Okay, I'm just going to give a very simple one here. I'm going to say 2, 5, 8, 11, 14, ... Hopefully what you see here, so the ... means that this sequence keeps going on forever. Okay, so we're going to keep going on forever like that. There's no ending to this sequence over here. So we just write ... to symbolize that this sequence keeps going on. Hopefully what you recognize is that this keeps going. If I add 3, add 3, add 3, add 3, that's how I can get into the next term. Okay, well, another way of writing this is like this. So what I'm doing here is that these 2 terms match up. The first term is 2, the second term is 2. Sorry, the first term is 2 and this one's 2. This one is begot by, well, if I start with number 2 and I add 3, that's how I'm getting this 5. For this one, I get 2 plus 3, which is the 5, but then if I add another 3, that's how I get the 8. For this one, it's 2 plus 3 plus 3. This is where I got the 8 plus an additional 3 gives me 11. 2 plus 3 plus 3 plus 3 plus 3 is 14. Okay, so what is it? We're starting at 2, and then we're continuously adding 3 every time to be able to get this guy over here. Okay, now another way of working this over here is I call this guy, this is my first term, T1, and that means this guy is T2, this is T3, this is T4, and this is T5. Okay, so what we're doing over here, when we talk about the general term, what this gives us is a formula to determine any term in the sequence. Okay, so if I had to figure out the 5,052nd term, I wouldn't go and do that 5,052 times. I'd hopefully be able to generalize this using a formula and use a formula to figure it out. Okay, now what we're doing over here, in the first term, it was just 2, just the first term. In the second term, I added 3 once. In the third term, I started with 2 and added 3 twice. In the fourth term, I added 3 times. In the fifth term, I added 3 4 times. So the idea is like the number of 3's every time is always 1 less than the term number. So here's how we're going to see our general term formula. So Tn, I can say n can be any, I can say natural number. And that just means 1, 2, 3, 4, 5, 6, 7, 8 number, and so forth. Okay, so any natural number. It has to be a whole number, but it can't be negative. It can't be any fractions or decimals. And term 0 doesn't make sense because there's a first term, but there's nothing before that, right? So Tn, where the n is going to be any natural. This is what we call the general term. All right. All right. So in this case, it's Tn equals 2, our first one. And what we're saying is that the number of 3's is always 1 less than the term number. So my term number is n for some unknown value here. It's going to be n minus 1, because this is 1 less than the term number here, times 3, okay, which equals 2 plus 3n minus 3. 2 minus 3 is negative 1. It's going to be 3n minus 1. So in this case, Tn equals 3n minus 1. This is what the general term would be for the sequence over here. Okay. Now, if I want to generalize this for any arithmetic sequence, we're going to say this: T1 equals your first term. N equals the term number. So it's going to be the first, second, third, fourth, fifth, or nth term. Okay. And I'm going to say D is the common difference. So in the previous example here, our common difference was 3. So if I want to apply what we did to this point right over here, Tn equals 2 was our first term, T1, plus n minus 1 times D. Okay. Now this guy over here, you do not need to have it memorized. You probably will after the end of this section over here, after you've practiced a bit more. But this guy is what we call our general term for an arithmetic sequence. Okay, so here's a general term for an arithmetic sequence. All right, so here's how we do this one. Example 5. Determine the general term of each arithmetic sequence. Okay, so we have Tn equals T1 plus n minus 1 D. Okay, so T1, this is the first term. N is the term number. And for general, we want to keep this general, so that's why we leave as an n in this case. And D is the common difference. All right, so in this case, I have 5, 12, 19, 26, dot, dot, dot. Hopefully what you're seeing is we're going 5 plus 7 is 12, plus 7 is 19, plus 7 is 26, okay? So in this case, T1 equals 5, and D equals 7. So I'm just going to write this down below here. That means Tn equals T1, which is 5, plus, we keep the n in here as an n, because I want to be able to use this formula to figure out any term that I want, times 7, okay? All right, so we're going to do a bit of simplifying over here. So to simplify this, we can kind of multiply these brackets over here, the 7 through the brackets like this. I can multiply this times this, and this times this, and I get Tn equals 5 plus 7n minus 7. That means Tn equals 7n minus 2. Okay, so this is the simplified version of our general term over here. Okay, now what's saying over here is asking for what T19. So it's asking for the 19th term of this sequence. Okay, so one, I could do it the long way. I could just add 7 19 times until I get the 19th term over here, right? Or if I use this formula here, T19 equals 7. My n value is 19 in this case, so 7 times 19 minus 2. Then just go into calculator, and you go 7 times 19 minus 2, and the answer is 131. Okay, so this, hopefully guys, you see that this is actually quicker than doing this out 19 times. Okay, well, maybe it wasn't for this example, but over here, guys, we have to do it 31 times, and this guy over here we have to do it 513 times. Okay, so we're not going to do it this many times. We'll be able to apply a formula, which will be able to make it easier. All right, take a look at example B. We have Tn equals T1 plus n minus 1d. T1 plus n minus 1d. And in this case, T1 equals negative 8. And d equals 6. Because it's negative 8, plus 6 is negative 2, plus 6 is 4, plus 6 is 10. Okay, so our common difference is 6. That means Tn equals T1, which is negative 8, plus n minus 1 times 6 is Tn equals negative 8 plus 6n minus 6. Negative 8 minus 6 is negative 14. Tn equals 6n minus 14. All right, okay, so here's what our general term is going to look like. Okay, so here's our general term for the first part. Now it's asking us for what's T31. So T31 equals 6 times 31 minus 14. Okay, calculator time, 6 times 31 minus 14 equals 172. And that's this answer here. Okay, same idea for example C. It's in this case we are subtracting 4. So 54 minus 4 is 50, minus 4 is 46, minus 4 is 42. So every time that, so in this case T1 is 54. Our common difference is negative 4. Okay, so difference is negative 4 in this case. So again, our formula is Tn equals T1 plus n minus 1d. Okay, equals T1 is 54. We keep the n in here, n minus 1. Our d value is negative 4. Okay, so that means Tn equals 54. Oops. It is negative 4 times n is negative 4n. And the negative 4 times negative 1 is positive 4. Okay, so we have Tn equals negative 4n plus 54 plus 4 is 58. Okay, all right, term 513. Just going to put an arrow and do this over here. Term 513 equals negative 4 times 513 plus 58. Calculator time for this, negative 4 times 513 plus 58 equals negative 1,994. All right, maybe that's a bit better there. Perfect. Okay, so this is how the general term works for arithmetic sequences. All right, example 6. How many terms are in the arithmetic sequence 6, 19, 32, ... comma 58? Okay. Now for this question is really not that difficult. Okay, so how many terms are there? The idea is like that we have this term, but the sequence is actually stopping at this number 58. So I want to say, is this the, the 10th term, the 11th term, the 12th term, or what term number is this guy here? Okay. Well, this one again, like I said, not that difficult. Okay, and the reason is we're just going up by 13 every time. 6 plus 13 is 19, plus 13 is 32. So the sequence goes 6, 19, 32. 32 plus 13 would be 45. 45 plus 13 would be 58. Okay, so writing out the sequence like this is this. Okay, now really for a question like this, if you had a question like this on a quiz, I would definitely do this question this way. Okay, so you're using good logical reasoning. You've done patterns for a whole bunch of years in math like that. You should be able to figure out this question this way. Okay, so what term number? So this is the first term, second, third, fourth, fifth. That means this is T5. So there are 5 terms. Okay, so we're done. More difficult for example 7 now. Okay, now the reason is I could do the exact same thing. Okay, so I could go and write this guy out. It looks like a common difference is 9, so negative 13 plus 9 is negative 4, plus 9 is 5, and so forth like this. And if I keep adding 9 to a whole bunch of times, I'd eventually get 176 over here. Okay. Now, what we want to figure out is there is a more algebraic way to do this over here. Okay. So looking at this, we know that T1 equals negative 13. We know that our common difference is 9. Now this term is the last term in the sequence that we have, but we don't know which term number it is. So what we're going to call this guy is going to be called Tn, but n is a question mark. So we don't know what the term number is, but we know the value of that term is 176. So we know Tn, but we don't know n. We want to come back to our arithmetic sequence formula, and this guy is on your formula sheets, guys. You do not need to have this one memorized. And we're going to plug in everything that we know. We know that Tn is 176. So this number gets substituted in to this value over here. So we have 176 equals T1 is negative 13. That goes in right here, negative 13. Plus, we don't know this value here. So I'm going to keep this as n minus 1 like this, but we do know that our common difference is 9. Okay, so now we have to do a bit of algebra, and we have to get this n by itself. So to start that, I have this negative 13, I want to get rid of it. So what I'm going to do is I'm going to add positive 13 to both sides of the equation, because negative 13 plus 13, those two terms cancel out, and we get 189. Next thing I'm going to do is I want to get rid of this 9. So this is n minus 1 times 9. So the opposite of times 9 is divided by 9. So I'm going to divide by 9 like this. The 9's cancel out here. 189 divided by 9 is 21 equals n minus 1. And then if I add 1 to both sides, I get an answer of 22. Okay, so what this is saying over here, this is T22, or to answer a question, there are 22 terms in this sequence. All right, example 8. Okay, so determine the arithmetic mean of 7 blank blank 15. Okay, so what this question is trying to get at is well, it's fill in the blanks, given that if we're telling that this is arithmetic, that means we know that there is a common difference. Arithmetic means there is a common difference. Okay, so looking at this sequence over here, we know that this is T1, We do not know T2, we do not know T3, but we do know T4. T4 is 55, okay? So let's kind of write down what we know. We know that T1 equals 7. This, if I want to use this term in the sequence over here, T4 is 55, and that means that n equals 4. So this is the fourth term, so we know that n equals 4. What we don't know is we do not know the common difference yet, okay? So to figure this one out over here, here's what we're going to do. We're going to use our Tn equals T1 plus n minus 1d formula. I'm going to plug in everything I know. In this case, n is equal to 4, right? So that means the n is equal to 4. So this would be like T4 equals T1 plus 4 minus 1d, okay? Well, I know T4, it's 55. I know T1, it's 7. 4 minus 1 is 3. I do not know what my common difference is here. Okay, so now let's just do a bit of algebra, solve this equation over here to figure out what d is. First thing, I can get rid of the 7, go minus 7 minus 7. 55 minus 7 is 48 equals 3d. Divide by 3, divide by 3. 48 divided by 3 is 16. 16 equals my common difference. Okay, so from here, I'm not finished yet. If my common difference is 16, that means if I start here, I add 16, and I get 23. 23 plus 16 is 39. And if I go 39 plus 16, it takes me back to 55. Okay, so I can kind of fill in the blanks of this arithmetic sequence once I figured out that my common difference is 16 over here. Okay, and that's how this question works. Okay, example 9. Determine the first term in an arithmetic sequence where the sixth term is 72 and the 15th term is 225. Okay, so quite a difficult question over here. There's a few different ways of doing this one. This is the way that I prefer doing this one over here, and hopefully you guys agree and you're able to follow this on. What I'm going to do over here, determine the first term. So this is what we're looking for, T1. Okay, and then we have T2, T3, T4, T5. The sixth term, T6, is 72. Okay, so we know this guy. So we don't know the first, second, third, fourth, and fifth, but we know the sixth term is 72. And then we have seventh term, 8, 9, 10, 11, 12, 13, 14. The 15th term is 225. And like, I'm going to put commas in between all these because these are values like this. Okay, so we are trying to figure out what this value is over here if we know this one and know this one, and we know it's arithmetic, so that means it does have a common difference is what this is telling us over here. All right, so here's what we're going to do for this. This is T15. For the moment, we're going to pretend that these five terms up here don't exist, okay? And what I mean by that is I want to rename, I'm going to pretend that this is actually my first term, T1, okay? And that means this is second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. That means this is my T10 term if I'm counting this as my first term over here, okay? All right, so what I want to do is similar to what I did in the last example and figure out what the common difference is. And if I figure out the common difference, that means I can fill in all these values and I can work backwards and fill in all these values to get back to this guy over here, okay? So if I call this guy T1, 72, T10 is 225. That would mean Tn equals T1 plus n minus 1d. T10 is T1 plus 10 minus 1d. Okay, so now what's my T10 value? Well, my T10 value is 225. My T1 value is 72. 10 minus 1 is 9, 9d like this. Subtract 72 from both sides. Okay, and 225 minus 72 is 153. Yeah, equals 9d. Okay, now divide both sides by 9. 153 divided by 9 is 17. So that means my common difference is 17. Okay, so I don't need to do this, but if I want to fill out these values over here, 72 plus 17 is 89, plus 17 is 106, 123, 140, 157, 174, 191, 208, and then plus 17 would be 225. So it kind of works out this way. Now, if I'm looking from left to right, I'm adding 17. Well, if I want to start going backwards, well, the opposite of adding 17 would be subtracting 17, right? So if I go 72 minus 17, I get 55, minus 17 again. You guys use your calculator for this. You do not need to do this in your head. Is 38. Minus 17 is 21. 4. And I get a negative 13 over here. Okay. So all that work at the end is to figure out this term over here, which is the first term, which the question's asking us for. So the first term is negative 13. And this is my final solution to this question here. Okay, example 9, on to example 10. Plumber charges $150 for a house call plus $90 per hour or part of an hour afterwards. Okay, so so if you ever need any kind of a plumber to come to your house like that, they do charge a fee for this. They charge you a base fee to come out, and they charge you something hourly afterwards. Okay, now the tricky thing is it's $90 per hour or part of an hour. Okay, so if plumber comes in, charges you $150 to show up, even if the job takes them 5 minutes, they're still going to charge you for the full hour. Okay, so just filling out this chart here: 1, 2, 3, 4, 5, 6, 7. First hour would be 50 plus 90 is 240, and then plus an additional 90 would be 330, 420, 510, 600, 690, 760. Okay, so point is, guys, if you're good at being a plumber, there's plenty of money to be made like that. You know, if you're good at what you do like that, you know, you can make a lot of money doing that. All right, so really the idea is like this is a form of a geometric sequence. So the first hour is 240, then it's going plus 90 every time over here. So if I'm going to generalize this in a formula, I'm going to go Tn equals T1 plus n minus 1d. And again, the reason why I can use this formula is because every time it's going plus 90, plus 90, plus 90, and so forth like that. Okay, so all right, so my formula will be Tn equals T1, which is 240, plus n minus 1 times 90. It's my common difference. That means Tn equals 240 plus 90n minus 90. 240 minus 90 is, so we have 90n plus 150, which if you look at the question, this is the original base fee, or the house call over here, and then $90 per hour afterwards. Okay, so this would be this question summarized in a formula over here. All right, guys. So I know that, guys, this lesson was fairly long, and hopefully this video lesson kind of makes a bit of sense for you guys, and I'll try to make some more of these for the rest of this unit. Okay, hope this makes sense, guys, and I will see you in the next video. You got this, guys. Bye.